Hello and welcome to this LUSAS online event. Your presenters today are myself, Philip Ike, and my colleague Steve Rhodes. We're talking to you today about why we built LUSAS 16 and what it means for you as engineers. And that has three main thrusts. One is the simplification of the interface to make it easier to use and more efficient for you. The second is enhanced collaboration that makes it easier for teams to work together, whether they're in LUSAS or whether they're sharing cross-discipline using industry standard formats and platforms according to BIM standards. We've also improved our design capability and extended the workflow for the engineer out of analysis into comprehensive steel design and a greater capability in concrete. So today's presentation is going to focus mainly on the simplification of the workflow for the engineer using this new version. This adds to existing information that you can find on our website. If you want a more general impression of the product, there's a video hosted there at lusas.com. We value your interaction during the event and encourage you to do so. Please enter any questions into the webinar panel and we'll come back to you with answers later in the event. So what does LUSAS 16 mean? We want it to be faster, more efficient and friendlier in order that you as engineers apply it to a greater variety of your infrastructure problems. In order to do that, we've streamlined the interface, removed clutter, made it easier for you to concentrate on production. We've given you new tools to make results easier to understand with greater clarity. We've extended the workflow out of analysis into design tools for steel and concrete. And we've enhanced the report writer to make it easier to generate the report in exactly the format you want according to templates and to easily create revisions whenever a project changes. So part of streamlining the interface is understanding what type of analysis you're going to do to start with. So whether you're doing a two-dimensional grillage, a two-dimensional structure, a three-dimensional structure, or an axisymmetric, LUSAS will adapt the interface to suit and reduce the clutter that the engineer has to deal with. In presenting results, we've enhanced this, so using the results locations, you can now get any result you want at any location on the structure, but that location is fixed. Any change to the model, you can easily report the information out at that same point. Averaging has been improved. It's now smarter and easier to use. Slicing is quicker. The viewing is easier as it gets superimposed directly onto your model view. And all of this information you can now combine directly with a report. And any changes to the model, you can regenerate that information directly, updating the report or the information on screen. As extending the workflow, we've got new tools for comprehensive steel design. This allows the engineer to design to a variety of codes of practice and to produce a detailed summary report, allowing him to see every step, every clause, every derivation in the calculation, making it easy to share with checkers and client alike. The Steel Designer will be subject to a further webinar. In this presentation, we'll be concentrating on concrete. For reporting, you can now put everything in your report. That comprehensive report, including input information, output information, textual and graphical information, is far easier for the checker or client to understand, can be put into a variety of formats that may relate to the project standards that they're working to. Any change you need to make to the model, the report can be updated instantaneously. I'm now going to hand over to my colleague Steve, and he can take you through the product in action.
Okay, thank you, Philip. I'd like to add my welcome to you as well. You should now be seeing the LUSAS version 16 interface with this curved girder bridge on the screen. If you're familiar with the LUSAS interface already, you'll notice a few updates straight away. The panels that can slide away, and as I hover, they reappear, as you can see here. And you can also pin them to retain them on the side of your screen. That just gives you a little bit more modeling space if you like. We've got all the usual tools for drawing points and lines, geometry, rotating and zooming, panning, all those things. And we've now got this option which is switched on, as you can see, for a true perspective view. And this is in fact a full 3D model with shell elements representing the deck and the webs, with beam elements representing flanges and stiffeners, bracing and so on. So it's a mixed shell and beam approach. And you can see if I drag my one of my saved views across the transverse moments there in the deck slab, but I can also quickly and easily see the composite moments, the sliced moments. That's part of a big overhaul of the old slice resultants tool, and these will now appear on my model as a diagram, as you can see here, so I can see the bending moments very quickly. So that may be something you wish to explore if you're doing bridges or structures where you want that kind of output. I'm going to show you how to create a bridge deck model, something simpler than this one, showing the whole workflow in overview. If we could have the PowerPoint back for a moment. So I'll take you through creating a simple bridge deck model, viewing some results, generating a report, making corrections to the model, using the traffic load optimizer, and carrying out some reinforcement checks. So here's the deck concerned. It's 10 meters wide and 500 millimeters thick, with main reinforcement of 20 millimeter bars at 150 centers. The carriageway is a total of 7.4 meters between the curb lines. There are 3 spans, 15, 20 and 15 meters, and because these are continuous over simple supports, we're going to analyze the deck alone rather than the whole structure. It's not integral. Of course, in LUSAS you have the flexibility to model the whole structure when you feel that's the best option. Also, there on plan, the deck has a skew of about 35 degrees. So returning to LUSAS, I'm going to start a new model and give that a name, Skew Slab Deck. And I choose now an analysis category. Those are the 4 options which Philip has already mentioned. And in this case, I'm choosing to create a 2D grillage or plate model rather than a 3D model. I can change my mind downstream, of course, but this option streamlines the choices that I make and avoids me getting muddled with options that may not be valid. I can choose a startup template, but I'm not going to use that in this case. I'm just going to start with a fresh, empty model. Now, the first thing I'm going to do is create a layout grid, and that's absolutely optional. I can create a grid which may be rectangular, circular, skewed. Well, that might be useful in this case, but I'm going to keep it quite simple and just put in a number of lines here, and a number of lines over here. So it gives me actually a sort of 5 meter grid. I can have several of these grids if I wish, and it's just simply there to help me create surfaces quickly. In this case, surfaces. Of course, it may be a beam model or a volume model which you wish to use your grid with, and that's absolutely fine as well. So I've created these surfaces, and if I don't wish to see that grid anymore, I can turn it on and off at any time. Traditionally, having created some geometry, some points, lines, surfaces, volumes in our model, we work down the attributes menu to describe the other characteristics of this particular structure until at least we reach this, this bar, which indicates that we have all the attributes that we need for a linear static analysis. So I'm going to do exactly that, starting at the top with a mesh, and it's a surface model that I'm doing here, a plate model. So I'm going to go to the surface attribute, and you'll see it's very little changed to those of you who already know the software, but this list here is now extremely short because LUSAS is already sure that you're doing a 2D kind of a model. So if I choose 2D thick plate there, or thick plate because they're all two-dimensional, and I can OK that, it appears as a little icon, and I can then assign that to the parts of the model where it applies, which in this case is all 3 of my slabs. Now, of course, I do need to have a skew in this deck, and I can do that by just moving these lines in the X direction. And you'll notice how the elements, the mesh, are updated just as I make my changes to the geometry, and I can do that all through the modeling process. Something else I can do is decide on a size of element. I can do that within the element definition, the surface element definition, or I can do it by controlling the divisions on each line. So if I use attributes mesh and line, I do have a choice of elements here. I might wish to include some grillage elements with my plates, that's perfectly valid, or some joints, but you can see, those of you who know the system, it's a much shorter list. But in this case, I don't want any elements, I just want to have an element length of 2 meters, and I can call that my 2 meter divisions. And when I OK that, I can assign that to any of the lines that I wish to assign it to. In this case, all of the lines in my model. And when I drag and drop, you see how the mesh updates. Working my way down the list now, I need a geometric property for these surfaces. I need to specify how thick the surfaces are. So the surfaces are 500mm or 0.5 thick. If you don't know how to convert between millimeters and meters, which I'm sure you do, but if you have feet and inches, you can also use the unit converter at any point. Anytime you see a numerical input and you'll see that little drop down, you can choose that. So let's put in the thickness there for my deck. And if I assign that, drag and drop it again to all the surfaces in my model. You can see now that's fleshed, and if I rotate around a little, you can actually see the thickness is there, 500mm thickness, but that's not all that helpful in this particular instance. I prefer perhaps to see the elements and the lines and the points in my model as I go along the modeling process. Working down the list again, I get to the materials. This particular model is a concrete deck, so I can use concrete. I'm going to use the EU concrete for now, and maybe the bridge part of the Eurocode. And again, I can choose a grade. There's also a new advanced define option here. If I click on it, there's a new advanced define option which allows me to specify any cylinder strength and of course different aggregate types and so on as well. For now, let's just choose, say, grade 50, and I OK that. And again, add it to the parts of my model where it applies, which is in this case, all of the surfaces in my model. Again, working down the list to the support attributes, when I look at this attribute, you can see I have now only the options which are available for a 2D grillage or plate model. So I can choose, let's say, a rigid fixity in the Z translation, which is just a sliding support or a bearing. Let's call it sliding. Okay. And I can assign that to the lines in my model where the supports actually occur. And keeping on down the list, I can go to the loading menu, and you'll find on the loading menu many loading options. I'm going to keep it simple for today and just start with a global distributed load. And I'm going to put in a global distributed load per unit area, which is going to replicate some surfacing. So my surfacing is maybe 75mm thick and 26 kilonewtons per meter cubed. And I can put that in just as an expression if I wish. And when I press OK, LUSAS will figure that out for me. Anytime you see those numerical inputs, you can use a kind of expression of that form. And if I just choose the surfaces where that applies once again, and I drag and drop my surfacing, I can put that into a load case. Let's put it into a load case called surfacing, in fact. And I can see little blue arrows. If I rotate around, you can see the blue arrows pointing downwards, which is a good sign. And if I go to perhaps my load case, I might wish to call this my dead load. And I can add gravity just like so. I've now completed everything that I need to do for a linear static analysis. So I could just press the solve button and LUSAS will run and give me the results. So straight away I see I have some deformed mesh. And I may wish to add, let's say, a contour. So I might add a contour of moments. Let's say moments on the plates in the X direction. That's the global X direction. There are transformation options here as well. But if I OK that, you can see, drag that up there as well so I can see the elements as well. And you can see the moments in my model. I might like to save that and call that my plan view. New facility, which I think Philip has already mentioned as well, is here on the Utilities menu. It's Graph through 2D. Now, that's been around for a while, but it has been updated, and I'll just demonstrate that for you. If I just drag a line across the model like so, you can see now that I can choose which low cases I wish to slice. So I might slice all of the low cases. I can choose an extent. In this case, the visible model is fine, or I can use a group if I have some groups in my model. As I hit next, I can choose to look at results. Those may not be the results that are currently on the screen, but I'm going to use moments mx as well, just to keep it simple. And a new function there, I can choose the width, a corridor width for averaging along that slice. So instead of getting a nodal result along the slice, I can have a width of corridor, let's say 1 meter width. And if I finish that graph, you can see I get the graph on the screen as I used to get in previous versions of the software. But I get a new option as well, which is that I'm able to see the graph as a diagram. So just as a bending moment diagram, if you like, right here on the model. So you can see I have now the option to show a diagram of force moment thick plate at the graph locations. And this gives me all of the different options that you'd expect from a plate element. In this case, I'm looking at the MX results. If I OK that, you can see the graph that's been created there, which runs over the top of the contours. Of course, I can change the color. I can have many of those slices across the model if that's what I wish. I might save that view as well. Having saved views is very useful because you can just drag and drop them and jump between those views and between different low cases by dragging and dropping as well. So you can see the numbers are updating there and the view updates as I drag and drop. I might also want to make some checks on my model, perhaps get some tabulated information so I can launch the print results wizard. This has also been updated. I can choose to look at maybe all of my low cases and look at displacements, moments, anything that I want in a tabular form. Let's have some reactions. And I can choose that to be, in this case, I'll have tabular and summary results. If I give that a name, and when I OK it, it appears over there in the attributes tab of the tree view, as well as appearing here on screen, so I can see all the various numbers, and I can export those to Excel if that's what I want to do. And anytime I want it, if I close that, I can relaunch it from this context menu. When I've got some saved views and some results in this way, it might be a good idea to create a report, something that I might pass on to a checker or to a client. So I create a report here, let's call it my report. And again, I can choose units, so they may be different from the units that I've been working in so far. I can put maybe a plan view on the front page. I can use this option to eliminate the breaks between chapters. That lowers the amount of the white space that appears in a report. And if I right click here, I can add chapters. So I might include some input data like the point coordinates and the material properties, any of these things. I can go to the results tab to add any results that I've already accessed. So I can include those reactions, or I can hit the new button and add some more. But perhaps I don't want so much tabular results as I want some graphical results. The graphs that I've created, I can also add in those. Or the saved views. I could say, well, let's include all those saved views. And in this case, I might have them for all of my various load cases. So again, I have complete control over which load cases are included. There's a notes tab here where I can add information about why I created a particular model. So I might say thick plate elements are used for, and then I could give some reason. I can call this my element selection note. And then you'll see that appear in the tree view here, and I can add it to my report as well. OK that. Anytime I wish to, I can now view that report. And what LUSAS will do is compile the graphical data, the saved views, the graphs, the tabular output, all of that absolutely live from this current model. So you can see straight away I've got this report. It's 10 pages long. You can see the point coordinates, the graph there, and various output which I've required, and the note at the end, a very short note. This has all been improved, as you can probably see if you're familiar with the reporting, just to make it clearer for people to see what they're getting. Okay, around now, perhaps I noticed that I made quite a big error when I first created this model, and that is that I got the skew in the wrong direction. So I would need to make a correction to my model, and I could maybe move that line to ×7 in the X direction. You can see now I've got a skew which is now correct. Of course, that invalidates all of my results. Now, hopefully you don't make that kind of error in your own modeling process, but if you do, or whatever error you do have to, or modification you do have to make, it's simple now. I can resolve the model, and immediately I'm seeing new results. And again, I can go to the report, view the report, and all the results are being recompiled, the tabular results, the graphical results, and I see it all revised in this new report. And you can see straight away from the front page, in fact, that this includes all the new data from my model. Okay, a couple of things I'd like to show you before we move on to the traffic load optimizer and the designing functions. One is what happens when we make a mistake in our model. So let's say somewhere along the line we made a mistake. For example, we didn't assign, I'm just going to deassign it, we didn't assign a material to that particular surface. Now in a small model like this with only 3 surfaces, it's probably quite easy to find an error like that, but in a larger model which may have thousands of surfaces in, it's sometimes could be potentially time consuming to find a small error of that sort. Along with that, I'd like to show you the model merge facility. So here on the file menu, we've got a bunch of import and export options, including the IFC file, which you can find down here for BIM compliance. But right now, I'm just going to dive in to the model merge options here and just find a curb line model. Obviously, when you merge models, you probably include more things than just curb lines. This is a very simple example, but it just gives you an idea. The function works by importing that model. Those curb lines then get drawn straight across, and also would be brought in any load cases that I had in that second model. Any attributes that I had in the second model will be merged in. Obviously, there are none in this particular instance. So now I've got a model with an error in. The error is known to you and me. But if I press the save button, give it a new name maybe, and I save and solve the model, then I see an error has occurred. It says, please refer to the text window. Well, the text window's down there. And I scroll up and see surface 2 has no material or composite properties assigned. So there's my problem. I've got no materials at some surface, some numbered surface in my model. And if I don't know what that number is, I can do this. I double click on that message. And this comes up with the identify object dialog. It says the selected message refers to planar surface 2. Would you like to do some of these things? Clear the selection, select that surface, pan so it's in the center of the screen, and perhaps create a temporary indication. That sounds good. So if I press OK there, you should see I've identified surface 2 very, very easily, and that enables me to fix the problem, add the material back to that surface. Of course, I could paint the surfaces with colors indicating which ones have which materials, but we're not going into that one today. So now I've hopefully fixed that problem. I'm going to go on into the traffic load optimization. We've already got the curb lines in place. If I work down the attributes menu and find the influence analysis, I can choose what exactly is the result of interest for me here. So maybe it's a force or a moment, a shear force maybe, or a bending moment. Let's use moments in the global direction, similar to those that we were looking at for our dead load. And if I OK that, I can choose a number of locations, or indeed the whole model, where I would wish to see those moments being optimized in order to then add them with the surfacing load, the dead load, and temperature loads, any other load cases which I would have in a real project. So I'm just dragging and dropping those across. I can choose the search area to be the nodes in my model, and I'll press OK there. I can see those influences have been generated. Now I select the curb lines. Those show where my traffic loads can go. In fact, these curb lines are a distance apart. If I go geometry point distance between points, I can see that they are in fact 7.4 meters apart. That's more than 2 lanes in the Eurocode. So if I go to the traffic load optimizer, on the bridge menu here, choose vehicle load optimization, and I will get a selection of different countries and codes which I can look at. Obviously, many of these may be of interest to you if you're watching this from China or wherever else. I'm going to go for some European options and choose, well, we have Denmark, that's new in this latest version. Sweden, there are two, there's an update there. I'm going to go for the UK. I can choose optional code settings. These will obviously depend upon your local code of practice. So I'm going to look at the ULS case. I don't necessarily need to look at all the combination and frequent cases. I can see which load models are being included and which vehicles. I can choose any or all of those vehicles to be put in. And it's including the associated load model 1 alongside my load model 3, my special vehicles there. I can choose to see just the onerous effects at those 3 points of interest, or I can choose to actually see the load patterns for each of those points of interest. So those are quite useful options. Defining the carriageways there from the selection, they were imported from my merged model, and then I can choose which influences are going to be calculated, and I'm going to just choose to have positive hogging in this case over the supports and negative sagging in the other areas. When I press OK, LUSAS will run the influence analysis, and then it will calculate using the influence surfaces the location for each of my loads. I've finished it before I've explained. The locations of the lanes, if I just drag and drop, show you the loads there, you can see, let's look on plan, you can see the special vehicle here, which has been placed very close to that sagging moment of interest. You can see in the same lane, load model 1 tandem, lane 1 tandem that would be as well, and I can open out and see the various factors that have been used here according to the UK National Annex. And then in lane 2 I've got a tandem very close, and then there's the remaining area because I've got two 3 metre wide lanes, so it'll be 6 metres, so there's a 1.4 or 1.6 metre wide remaining area, if I could just remember the width of the carriageway there. And again, over here for the sagging in this area, you can see how the lanes have been changed around and the areas which are loaded have been changed in order to give me the most onerous locations. Okay, so now I've got a variety of load patterns. I can press the solve button. That will give me the actual bending moments, both for the altered analysis one, because of course remember I took the material off, put it back on, and now also for the traffic load optimizer, or the VLO runs. And I can look then at the dead load results and the moment results and so on, and see the bending moments for each. For my design, obviously I need to combine the different load cases together with factors according to, in this case, the Eurocode and the UK National Annex. So if I go to the design menu, there's a new option here which is design combinations. There's still the existing options that we've always had for basic combinations, smart combinations and enveloping, and the design combinations occur here as well so that I can find them easily. I choose the design code that I'm going to work to, so I'm going to work to the Highway Bridge National Annex for the Eurocode, and now I can categorize or give a type for each of these load cases, and these would be traffic loads, and they are characteristic. When I hit the next button, it takes me on to ask me which design combinations I'm interested in: persistent, accidental, seismic. I'll just go with the persistent there. I can have some SLS combinations as well if I need. And if I want to look at the factors that are being used, I can see them on the advanced button there, all the permanent factors. Obviously these categories, these types will depend upon which code of practice you're working to, as will the favourable and unfavourable factors. I can also choose whether loads are mutually exclusive or not. And so the traffic loads in this case, of course, are mutually exclusive. I've got a pattern. I can't have that pattern at the same time as another pattern, so I choose those to be mutually exclusive. I'm going to use the basic combination option. When I press finish, LUSAS generates a whole load of design combinations, and I can see it's tried every load case with every load factor that's possible in the National Annex, in this case, the UK National Annex. And so if I set that one active, I will get a combination based on the load cases that are included here and the factors that you see here as well. So I've got all of these combinations, and they can be compared, and I can then show the worst using the envelope. But before we do that, let's just have a little look at the Slab Designer and how that comes into play. If I go to the Attributes menu, a new option down here for design is the RC Slab Design. So if I go to the RC Slab Designer, I can come up with, was it 20s at 150? That'll do for my, let's say that's my main span. And when I press apply, that appears over in the Attributes tab of the tree view, and I can have another, which may have, let's say, a slightly smaller bar size for the side spans. I can choose spacings, different bar sizes, I can change the layers around, the cover requirements, even the angle of the rebar. And I can assign those into the different areas of my model. So in this case, I'm going to have my main span here, obviously, and my two side spans. There we go. Now I've assigned these different reinforced concrete attributes. I'm able to go to the design menu and do a slab design. Here I set whichever country I'm working in. Again, there's a whole range of different countries which may be of interest to you depending where you're watching from. So here I'm going with the United Kingdom, and I have a range of different codes of practice which I may be working to. So I'm going to use the Eurocode bridge part, and here a new option. Because I'm using a plate model, I've only got the option to use a bending check, not a bending with in-plane force check. If you're using a 3D model, you will find in version 16 you have that new option to look at bending with in-plane, that is overall tension or overall compression, taken into account. So that's a really useful new option. Here I can set the characteristic yield strength of the reinforcement and so on, and the allowable crack width if I'm going to do some SLS calculations later. These options are essentially unchanged from previous versions of the Slab Designer. When I press finish, I get this message telling me, just one off really, I can turn this message off, that the Slab Design has been improved and the results are going to come in through the usual layers, the contour and values layers, the same way that I've looked at all of the other results in my model to date. So when I press OK, if I now go over to the contours layer, I can choose from the list my slab design calculations to the Eurocode as I've selected it, and I can see I've got utilization maximum in the top face and maybe utilization maximum in the bottom face. Those are very useful ones. Let's have a look at this one. Let's select the bottom face there, and when I OK that, you can see the utilization in these areas. So obviously over here where the load is, where the traffic load is, I'm getting a very large, as 248% utilization there, a 2.48 factor, which is obviously unsafe. And unfortunately, that's not the end of the story, because that is only for that one combination. So if I now set active this envelope, LUSAS is going to compare all of these combinations, and it will at each node carry out the slab design calculations, slab design checks, to find the maximum utilization, bearing in mind all of those different combinations. And I can't show the deformed mesh at this point. Those calculations are now complete, and we can see the utilization there going up to well over 300%. So I can go and make some changes to the reinforcement here, or I could even go back and choose to look at a contour which shows me the requirement for steel in the X direction or Y direction in the top or the bottom, and therefore refine my design. I can add any of the contour plots or tabulated results that I wish to my report, and then generate more reports. But that really completes what I wanted to show you, just as a quick overview of how you get from end to end in the modelling of a bridge structure using LUSAS version 16. I hope you found that useful, and I'll hand you back now to Philip.
Thank you very much, Steve. We're going to take a pause at that point to respond to some questions. One question that we've had repeated in a variety of different ways is, what are you going to tell us about some of the more advanced features of LUSAS, particularly in terms of analysis? This is a big release for us, version 16. There are plenty of things inside it. You can find obviously a lot about that from the LUSAS website at lusas.com. For those of you that are users starting up your program, you will see in the README file a list of everything that is new in this version. But just give you a taste of some of the things that are new, particularly in terms of more advanced analysis. We've revised the interface for creep, so time dependency is better handled for creep in concrete. We've also put in a new interface for handling temperature dependency of materials. The cable tuning has been enhanced as well. It was previously a linear cable tuning function, and that now supports nonlinear geometry and material behavior as well. So we have many things. They're not going to be covered today. This is about making your job quicker, easier, more efficient, reducing errors. Further webinars will cover other content.
Okay, yes, thanks, Philip. I've got some questions here along the lines, what are the different analysis categories? You've got several different 2D categories. What's the difference there? And sort of along with that, have we actually taken away some options? So first of all, to say, absolutely not. We're not in the business of taking away your options, but in LUSAS version 16, we are in the business of trying to make it easier for you to find the right option. So if we can perhaps bring back that PowerPoint slide that Philip had earlier for the analysis categories. Thanks. Yeah, so in the example that we just used, we used that top left-hand category, the 2D grillage or plate category. As you can see, it's illustrated using a grillage here, but we used a plate element in the example. And what that really means is we drew in the XY plane and we loaded only in the Z direction. And so our drawing, if you like, our idealization was two-dimensional. And that would be true for any grillage type analysis or plate type analysis, until you have in-plane loads. For example, if you have an integral bridge, you might have soil pressures and temperature loads occurring in plane, giving in-plane forces, not just bending, but in-plane forces. And that's when a 3D model would be necessary, because you need to take that into account. Moving over to the right, the 2D in plane, the difference there is that we're drawing, if you like, the elevation, as you can see here, or it could be a section through a tunnel, or a section through a box culvert, or a section through a dam, anything like that, where we're slicing and we're drawing what is essentially an elevation or a section, and all the forces are applied in the same plane. So the vertical in this category is in the Y direction, it's downwards on the screen as we look at it now in the elevation. So there's no loads that are going into the page. There are only loads in the XY, loads in plane. The 2D axisymmetric, I think, speaks for itself. It's a slice on a circular object like this settlement tank here, or LNG tanks, these sorts of things which people use LUSAS for. Whereas everything in the real world, of course, is three-dimensional. And so you can always use 3D as an option. But this is actually a massive deal, in fact, because what it means is that in version 16, as you choose that category up front, all the choices downstream are rationalized. So when you're looking at the line mesh attribute, you can't choose a 3D element if you're working in 2D, and you can't choose a 2D element if you're working in 3D. And likewise, as you will have noticed when I went to things like loading options or the support options, you're only seeing the choices that you actually have to make. If you've ever got an error message that says something to do with using a three-dimensional beam element together with a two-dimensional geometric attribute, well, you won't get that error ever again now. So that's the sort of thing which can really save you a bundle of time. Philip?
Okay, thanks, Steve, for covering those. And that completes the practical demonstration of LUSAS 16. Just to reiterate, this is all about speed, efficiency, and a more friendly interface, a better experience for you as a user with this new release. Along with the release of the software, we're releasing additional media content to support that. We now have a new microsite. This can be read on any device. It's what's called a responsive website, so you can view it easily on mobiles, tablets, as well as PCs. There's new content on there that you can view and download. So as I mentioned earlier on, there is a more general video on version 16 which you can look at straight away, which will give you an impression obviously of some of the design and collaboration facilities that we did not cover in this event. We've also got a coupling now of social media with the LUSAS website. So Facebook, YouTube, LinkedIn and Instagram are our primary social media forms, and those are now displayed inside the LUSAS website, so you can see our live content stream there. You can interact with it, like it, comment on it, and please do. We encourage that sort of interaction. If you need help in using version 16, please rely as ever on our support team headed by Ahad Kalahi. They can help you obviously with what's new in LUSAS 16 as well as all the general inquiries that you may have on the use of the product. We will be doing other webinar events, and the first of those that we intend to do is on comprehensive design within LUSAS, the major facility within which is the new comprehensive steel designer. So look out on your email and on your social media. We'll be making announcements on that presently. But otherwise, it just rests with me to say thank you very much for attending today. We value your time. We look forward to your feedback on what you think of version 16. And we look forward to welcoming you to future events either online or in your offices. Thank you.